Vectors in space. So we're going to talk about how to graph in 3D a little bit and then how to do with vectors in 3D space. So if you've never seen a 3D graph before, this is what a 3D coordinate system looks like. Here's your x and your y, like a normal XY graph, right? If you think about it, like a basic XY graph. This guy right here is right here, x and y. It's kind of if you lay it down on its side. And then we have a z coming up. So x and y is the base, and then we have a z coming up. If you look at the dotted lines, those are the negative x and y. So like this, how this is a normal quadrant 1 only. If you expand it to 4 quadrants, that's what's going on here. So positive x, positive y, positive z, negative z. And that's what an xy coordinate plane looks like. So let's talk about how to graph or do a vector from xy. Okay, so when they give you a vector spot or a point, right, you can go from the origin. Now, we'll practice graphing this in a second, but the general idea is this. Let's say they gave you 2, 3, 5. So what you do is you want to go 2 on your x. So my x is right here. So they're going to go 2 on their x. It's along that line. And then from there, on your y, you're going to go 3. So you can go parallel to your y-axis and you go 3 on. So this spot right here, they ran 3 that way. And then from that spot, you go up because you're z, so you're going to go parallel to your z. You're going to go up the remaining 5. And then where you end up, that's your point P. That's your vector. Now remember, if we're writing a vector, you always want to draw it from the origin. So my vector will actually be the point from here to there. It's a little weird, but remember, it's in space. It's not like on a plane. It's going up in space. There's your x and y. It's going out there. But that's kind of how it works. It'll make more sense when we start doing an example. But the general idea is you go this amount on your x. You go from there, from that spot, you go this amount on your y. And from that spot, you go this amount, that amount up on your z. So let's try that. And other than that, this just lets you know, like, oh, I probably should say this, right? How when we do vectors in 2D space, x, y is I and j. Z is the k value. So, and if you see x, y, if you see it I, j, k is the z value. So, I and j are the x and y value, k is the z value. And just like before, if we do the base unit vectors, right? X is up here, y is right there, z is at the very bottom. So again, you can write it multiple ways. So let's first talk about how to draw a 3D graph. So let's do my my z, then my y, and then my x. To me, I think about it more as like a box, like the corner of a box or a room. Like I do kind of this thing. Draw a little parallel to that x. Draw a little parallel to the y. You get that. Draw this parallel to the z. Parallel to the y. And then I'm gonna draw this parallel to the z. And then parallel to the x. So kind of like this. So for me, I always think about it like a corner of a room. Not my best drawing, but that's the idea. So how does this work? We're gonna go 0 my x. So I'm kind of right there still. I didn't go anywhere. Then I'm going to go 2 my y. And then I'm going to go 0 my z. So that point is just like saying, go 2 in your y. That's it. Right? So you started at 0 in your x. And then you went 2 to the y. Then you didn't go up at all. So you just use 0. So it's point 0, 2, 0. Like that. Just to show some context, what if I gave you the point 0, 2, 3? Well, it still be 0, 0. 0 for x, so you start here. Then you still go for 2 for your y, so you're right there. But now there actually is a z of 3. So on your z, you should go up to 3. And that'll be the point. Right, so my x went nowhere, my y went 2, and then on my z went up to 3. So let's try 3, 0, negative 2. I'm not going to draw the whole box anymore. Don't need it. Y, Z. Ooh, sorry, that's X. And then Z. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So I'm probably a little more complicated this time. So I'm going to go 3 my X. So 1, 2, 3. You're currently right there. That's not your final point, but we're currently right there. On my Y, go 0. So I'm not going to go here at all. Then on my Z, I'm going up 2. Now, this will be a little different than last time. So last time I just went straight up 2 was easy. This is slanted. So if you go to 2, like right there, it'll be wrong. You're going way too high. So what the best thing to do is kind of draw like a parallel line. So here's my x, right? I'm going to draw a parallel line to my z through my x. So something like this. So those two are parallel. And then on my z, I'm going to draw a parallel line to where I want to hit. Where I want to hit 2. So I'm going to draw a parallel line at 2 of my x. So I'm not going to draw it like a straight line. I'm going to draw it like slanted like the x is. So kind of like this. And that point right there is where going up to according to the z value. That point right there would be the point 3, 0, 2. Right, another way to think about it is you go 3 in your x, and then from that spot, you go up 2. So 1, 2. So you'll be right there. So you don't want to go all the way up to 2 because you'll be low 4, because it's all in like respect to your x and y axis. So it'll be a point like that. Okay. Let's try that again with c. I'm going to have all 3 of them. And we have a negative x. Lovely. So here's z. Here's y. Then x would be right here. I do have to go backwards a little bit too, though, because there's a negative x. Okay, let me put some markings. 1, 2, 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. Okay. So let's try this again. So on my x, I'm going to go -1. So I'm just going to go back to 1 to like right here. So that's not my final point, but right now I'm at that point right there. On my y, I got to go 2. So 2, y is going to the right. So again, you don't want to just go to 2 in your y and make that a point. It doesn't work that way. From this spot, you want to go 2 over. So you see how you're starting a little bit further along? So that should be like 1, 2, be over here somewhere. But if you want to be correct about it, all you have to do is draw parallel lines. Since I'm on my x, I'm going to draw a parallel line at -1 parallel to y. So like I'm kind of doing these two right now, x and y. So at the point of my x, I'm going to draw a parallel line to y. And then for my y, I want to go to 2. I'll draw a parallel line at 2 of my y. But again, it has to be parallel to the x. I'm dealing with x and y. So I'm going to draw this line parallel to my x. So it's been like this. Give or take, right? Something like that. So if I just did -1, 2, I'll be right here. Right? So I went -1 on my x, and then I went over 2 to my y. Again, from that spot. Another way to do it, just think about parallel lines. Okay, now I gotta do the z. So I'm right here. So the trick to doing z is start at that point. From that point, we're gonna draw a line parallel to z. So right, that's the thing that's parallel to z-ish. And I want to go to 3 on my z. And I want to draw parallel to this point here. So here's a tricky thing about it. You don't just go straight across, because you have to be parallel to the y and the x. So what we do is this. From the origin, you go to the bottom here. And that's the line I need to be parallel, because right, that's like the vector of x and y, but I need to add the z in. So I'm gonna draw a line through 3 that's parallel to this red line here. So it's gonna look like that, kind of to that effect. And that point right there is my point: -1, 2, and 3. All right, if you have more time with that, the general idea is just kind of think about it this way. The idea is supposed to be, I'm doing it in green actually right here, a little thicker. Basically, the general idea is you start at your origin, and then you're gonna go -1 on your x, so you go back a little bit on your x, and then you go 2 on your y. So from that spot, you go 2 over to your y, and then from that spot, you want to go up 3 to your z. So if you're counting up, you go like 1, 2, 3, and that's the path your thing's making. You went x on your -1 on your x. You went over 2 on your y, and then you went up 3 on your z. That's kind of the way it works. Let's move on. If you want to find the magnitude of a vector. Oh, I never draw the final vector here. Sorry about that. Or for any of these. That is bad. The final vector goes from the origin to that spot. So that'll be the vector. Origin to that spot. That'll be the vector. and origin to that spot. I guess I drew 2 here, so 2 different vectors. So that's how you draw a vector in 3D space. You get to that point, and then you draw it from the origin. What if I want the magnitude of those vectors? Well, it's just like find the magnitude of a 2D space, just one extra component. Actually, in your formula sheet, this is what's on your formula sheet. They don't do the 2-component one. They don't have that one. All they show you is a 3-component version. If you only have a 2-component vector, just ignore this part and you're fine. Right? If you only have 2, just do this part. It's the exact same thing. How to find a vector between 2 points? Basically, how do I find a vector AB if I have the points A and B? Same as before. Tip minus tail. Right? Only difference now is I have 3 components, but it works the exact same way. So let's do an example to illustrate this. So I want to find OP, just like before. Don't let that get you. OP is the same as saying P minus O. O is always the origin, so it's really just P. So OP is the vector P, -3, 1, and 2. There you go. So we have this vector P. Remember, and this is a point P. Remember that there's a difference, a very important difference. Just to show you, point the difference again. Let's draw this real quick. Let's just show you. Right, this is X, this is Y, this is Z. -3x, of course, they hate me, so I have to go back. So it's a little faster. So you go 3 in your X, then we'll go over to my Y. So remember the way you do that is you start your X right here currently. And then from that spot, we'll go over one of my Y. So just like we think one would be in your Y, so about that same distance. So that's where I'm currently. And I still got to do Z, and then my Z I'm going to go up to, because Z is going up. So from there, like 1, 2-ish. So that'd be my final point. -3, 1, and 2. Right? And that's a point. It's a point in 3D space. That point right there. A vector is a vector. The vector P, OP is a vector from the origin to P. So this guy. Remember, OP is the same P. So that's a point. It's in coordinate form. This is a vector in the vertical form. How about PQ? Well, remember tip minus tail. Tip minus tail. Now again, it's PQ, so we're going from P to Q. So the tip is Q minus tail P. Q is 1, -1, 3, and then P is -3, 1, 2. So we get 1 minus -3, which is 4. 1 minus -1 minus 1, which is -2, and then 3 minus 2 is 1. So I get the vector 4, -2, 1, which is the vector PQ. Right, and now they want absolute value PQ, which again just means magnitude. So that's just a magnitude. Absolute value just means magnitude in vectors. So we use the formula: a squared plus b squared plus c squared into 3 components. And we're just going to type it all in there, sub it all in. Remember, when you square negative, it does become positive. So we should get 16 plus 4 plus 1, also known as radical 21. And that's the answer to that one. Vector equality, remember we talked about this before. The vector equality, 2 vectors are equal when they're going the same direction and have the same magnitude. So anytime 2 vectors are going the same direction, like these two, and they have the same magnitude, so the same length and size, they are parallel. If I tell you it's a parallelogram, which is what we tend to do with vectors, so if it's a parallelogram, the opposite sides will be equal because they'll both be parallelogram, and they'll both be the same magnitude because they have to fit inside a parallelogram. So anytime a parallelogram, just get dead giveaway that the opposite sides will be equal to each other. And that leads us to our last question. ABCD is a parallelogram with A is this, B is that, and D is that. Find the coordinates of C. So first I like to draw my parallelogram. So we're going to get something like this. Opposite sides should be parallel-ish. It doesn't matter where you start, it's A, B, C, D. It should be fine. Should go in order though, A, B, C, D. So I know A is that, B is that, blah, blah, blah. So how are we going to find coordinates of C? Well, it's a parallelogram. So that means the opposite sides are going to be equal vectors. So if I do a vector AB, it should be equal to the vector DC. So that's our whole goal. Find vector AB and set equal to vector DC. Well, how do we find vector AB? Well, tip minus tail. It's going to be B minus A. And then how do we find vector DC? Same idea, C minus D. Well, B, the vector B would just be the point B just put in component form. So 2, 0, negative 1. Vector A is going to be negative 1, 2, 1. C was keep C. And then D is 3, 1, 4. Don't know what I was thinking there. 3, 1, 4. So here we just add two, we just subtract them. So 2 minus negative 1 is 3, 0 minus 2 is negative 2, 1 minus negative 1 is negative 2. So that's the vector AB. And on this side, I still have vector C minus the vector 3, 1, 4. So all we do is, how do we solve it? Just like any other problem. You add this to both sides. Add the vector 3, 1, 4 to both sides. And then you get your vector C equals 3 plus 3, which is 6. 1 plus negative 2, which is negative 1. And then 4 minus 2 is 2. And that'll be the vector of C. Now, the question wasn't find vector C, though. It was to find the coordinates of C, which means it's put in coordinate form. So 6, negative 1, and 2. That's the point C, which is the correct answer. Right? It wasn't find the vector OC. It was to find the coordinate of C, which would be this. And that's the idea. We are done.